All right, now we're going to talk about complex fractions. Complex fractions are just that. They are fractions that look weird. There's lots of them. And really what we're talking about is a fraction divided by a fraction, all right? And it won't be top to bottom, it'll be, or it won't be left to right, it'll be top to bottom. So let's take a look at one of these guys. And let's keep it in numbers for right now, because eventually we will go to letters. 2/9. All right, so if we think about this, we can go ahead and top to bottom is left to right. So we can say negative 4/3 divided by 2/9, which is copy dot flip. And then we can reduce. We get 3 over 1, 2 over 1. Anything divided by 1 is itself, or anything divided by 1 is itself. Negative 2 times 3 equals negative 6. And that's fine and dandy. Okay, that's not the way I'm going to teach it today. I'm going to teach you a little bit different way to do this guy. So let's take a look at this guy again. Let's get back up here. Let's go negative 4/3 2/9. And all I'm going to pay attention to right now is my denominators. So let's look at my denominators, because really, if I got rid of those guys, I'd have a simple fraction. That's something I can do something with. So my common denominator between both of my fractions, or all my denominators fractions, is 9. So I'm going to take that. I'm going to take this guy times 9, both top and bottom. All right. And so here again, we're going to look at this guy. It's going to reduce. This guy goes to 1 and 3. And this guy reduces as well, and it goes to 1 and 1. Well, what does that get us? Well, across the top, we have that negative 4 and 3, which is negative 12. On the bottom, we get 2 times 1 and 1 times 1, which is just 2, and that gets us negative 6. So we can kind of get to that answer just a little bit faster. Not always, but it makes it a little bit easier. This is the way I'm going to teach you when we start talking about rational complex fractions, okay, or excuse me, expressions with complex fractions. So let's go ahead. Let's just do a couple problems. So let me get back to black here. Let's say I've got a 6 plus 2 over r. And I've got a 3r plus 1 all over 4. Yeah, I can go top to bottom, left to right, but this poses a big problem, especially if it were down here. This is probably an easier problem to do that with. But let's just look at all the denominators we have. All right. So we have a denominator here. We have two terms. This denominator is 1. We have a denominator of r there, and we have one denominator here because it's under both of these terms of 4. So my common denominator is between 1r and 4, which is simply 4r. So I take the top and bottom times 4r. Now this is 4r over 1, right? I do the top, I do the bottom. And now when I do this, I've got to distribute this guy. When I distribute this guy, I get 24r. When I distribute this guy, my r's will reduce, which means I only have 2 times 4, which is a positive 8, because that's what sign it was before. And notice how it just went to one simple fraction. I've got a numerator now. Here again in my bottom. Okay. When I distribute, my 4's will reduce. Okay, anything divided by itself. So I get this r times this guy, which is 3r squared. And when I take it over here, my 4's reduce again, right? Because it's still over that same guy. Okay, or I can think about just distributing this. The 4 drops out and the r goes to each and every term. Same kind of thing. Plus r. Well, now I'm back to simplifying rational expressions. So I have to find a greatest common factor here. Becomes 3r plus 1. I can factor out the r there. I get 3r plus 1. My 3r plus 1s go ahead and reduce. And in this particular problem, I get 8 over r. make it a little bit more difficult. 1 over a squared minus 1 over b squared, all over. Notice how it's starting to look a little goofy. That's 1 over b. Well, in this case, I've got 4 denominators now. I've got 1, 2, 3, 4 denominators. What's my common denominator of all 4 of those? Well, I list my bases, highest exponent. So I get a squared and b squared. Because I have a base a base b, the highest exponent of a is 2, the highest exponent of b is b squared. And so now I'm going to distribute. My a squareds will reduce. It leaves me with b squared. When I distribute again, minus, right? My b squareds leave and I get a squared. We do that down here to the bottom. Now remember, I know it comes down below, but it would actually fit in the numerator here. So I have 1 more a up top with this b squared minus, and I have 1 b that leaves. So I have an a squared b. Here again, I have to see if that reduces, right? So this may be my answer, but I at least have to check to see if this works. B plus a, b minus a, because that's a difference of squares. Here I can factor an a out of everything. I can factor a b out of everything. If I factor the a and the b out, it leaves me with b minus. I factor the a, b out of here. I get left with an a. And those guys reduce, looks like. So I get a b plus a all over ab. And there's my answer for that guy. A couple more problems to run through real quick. Make it a little bit more taxing to look at. Not harder necessarily. Plus 2 over mp squared all over 4 over mp plus 1 over m squared p. All right, so now, here again, I've got 4 terms. I've got an m, and I've got a p that I'm going to take this times, but I have to take the highest exponent. And this is the highest exponent of all of these guys. So it would be m to the 3rd. P looks like I have a p squared. Okay, so what I do to the bottom, I do to the top. So let's focus up here at the top. Okay, so as we're going to reduce, we're going to distribute these 2 guys. When we do, I get left with 1p up top, minus. When I distribute this guy, I have, looks like I have a 2. I have more p's or more m's on top by 2, and my p's reduce. So there's my new numerator. Here again, I've got space down below, so that's where I draw my arrows, but this actually goes into the numerator. So I've got a 4 in my numerator, and I've got more m's on top by 2, and more p's on top by 1. When I distribute this guy, I've got more m's on top by 1, more p's on top by 1. Now, this guy's primed. I can't get a p out of both terms, and the p's a prime term there. So this guy I've got to distribute, or excuse me, I got to factor. So this comes out, I can get an m out. The most I can get is 1. I can get a p, which leaves me with that 4m plus 1. But as you notice, I can't take that m out of both of these terms. I can't take a p out. I can't take a 4m plus 1, which means this guy, even though I looked and it factored, it didn't reduce with anything. So this guy that I circled is my answer on that guy. I still have to check to make sure it reduces. It is a fraction. And then let's do one that's got a little bit of length to it here. Let's go 1 over m minus 1 plus 1 over m plus 2. Let's go 2 over m plus 2, and then let's take it minus 1 over m minus 3. All right, so here again, 4 fractions, 4 terms on the denominator side, and 2 of them are the same. So if I just listed my bases, I have an m minus 1, I have an m plus 2, and I have an m minus 3. That's going to get rid of my denominators here. What I do to the bottom, or to the top, I do to the bottom. And here we go. Now I'm going to distribute each one of those guys, and then we'll distribute down here as well. When I distribute to the top, the m minus 1s leave, and remember I have to multiply that guy before I add, so I'm going to do that. You may have to watch this video a couple of times because I'm just going to distribute this guy, which leaves me this m squared minus m minus 6 from up top, plus when I distribute here, my m minus 2's fall out, and so I get this trinomial when I FOIL m minus 1 and m minus 3 of m squared minus 4m plus 3 all over, there again, my m minus 2's reduce, so I get left with a 2. And let's see, my m minus 2. So this m minus 1, m minus 3, which is this term, which was the last one, right? So I'm just going to copy that one. So hopefully if I did that right, everything else will be right. Oops. And then minus, and then my m minus 3's leave. And I get this m squared plus, m minus 3's leave, so this guy. So it would be plus 1m and then minus 2. All right, so now I have kind of a mess up here I'm going to have to clean up, which is not huge, but let's go ahead and let's get this guy going. So I've got on my top, I've got 2m squared, I've got minus 5m, and I got minus 3. All right, this bottom's going to take a little bit more because this guy I have to distribute. So I have actually, and let's just change colors, simplify some things here. So I've got a 2m squared minus 8m plus 6. Now remember I have to add the opposite sign here. So this is minus m squared minus m plus 2, because when I do that, this all becomes different signs. So when I combine like terms on this guy, it looks like I simply just have an m squared. It looks like I have minus 9m. That looks like I have plus 8. Well, that's great. Looks like I need to do a little bit of work over here to the side, but this guy right here looks like it might go to m and m, 8 and 1, minus and minus. Okay, so I have to factor this guy to look to reduce. This is actually my answer. I just need to see if it reduces. This guy's 2 factors of 6. All right, negative 6 that had to get negative 5. All right, so 2 factors of negative 6 to get negative 5 are 1 and 6, and it has to be a negative 6. So that guy factors as well, so we need to find out what the factors are, and I'm going to do that over here. Let's do this. So I'm going to do that over here. So 2m squared minus m, excuse me, plus m minus 6m, that'll give me that negative 5 in the middle, minus 3. I'm going to factor my front 2, my final 2. I can get an m out. Leaves me with 2m plus 1. I'm going to factor out a positive 3, excuse me, negative 3, which will give me 2m plus 1. And so I've got a 2m plus 1 and an m minus 3. Okay, so I'm going to insert that back up here. And so I get a 2m plus 1, and I get an m minus 3. And as you can see, we did all that work for nothing because nothing reduces. If we want to leave that in simplest form, this is actually the simplest form that we could use. And yes, you'll have problems that look like that. So good luck, have fun, don't fret too much.